Good morning, and welcome to our session. I'm Dimitris. I'm a technical evangelist in Greece, Cyprus, and Malta.
I'm Brian Peake. I'm a cloud developer advocate in Azure, focused on gaming technologies.
Yeah, we both love gaming. We both love helping game developers, be more productive with Azure. Here we have a short session about talking about multiplayer server scaling with Azure Container Instances. So, dedicated game server scaling for multiplayer game servers is a tough problem to solve, right? I mean, most of the times people are using VMs, and as you may know, VMs take some time to start, right? For if you go to Azure Portal and create a new VM, it may take up to 3 minutes to start. So, another issue also is that, well, if you want to scale down your multiplayer game servers, you just can't start and deleting servers, taking them down, right? Because people may still be playing games on them. So you need somehow to wait till these games have finished and then shut them down, right? So this combination of problems led us to create a small project which can be a solution for this problem. So to create a stateful, isolated multiplayer game server that would be as lightweight as possible, I mean, start as fast as possible, right? And able to terminate gracefully and, I mean, not start taking game servers down one by one, right? And, well, you get bonus points if you pay per second, and you have an automatic scaling. So we have created a small project. We will use OpenArena. We have 2 games, actually, in our repo. We have, yeah, it went out. Sorry. So we'll use in our sample OpenArena to test our game. I believe most of you guys have played here Quake, right? OpenArena is...
2 seconds? Yeah, sorry. Yeah. Oh, you're good. I just want to make sure everybody can hear you just clearly. There you are.
So OpenArena. Think of OpenArena as an open source Quake, right? You can download it if you want, because we will have some real action later.
Mm-hmm.
So we have created an open source project. It's on GitHub. It's written in Node.js. And we have the following components. We use a Docker container. We use Azure Container Instances. We use Azure Functions, Event Grid, and Azure Storage. Let's get some deep dive down on them. So I suppose most of you people know what Docker containers are, but if you don't know, think of them like VMs. Well, they're not VMs, right? Then if you check the slide, the image on the right, you will see that the main difference is that the VMs carry the kernel, whereas Docker containers don't have a kernel. So they are more compact, right? More lightweight, and most importantly, they start faster than a regular VM. I mean, in the Azure portal, a VM can take 2 to 3 minutes, right?
Or longer,
whereas in our ACI demo, it takes 2-3 seconds, right, to pull an image. And also the size difference is pretty huge. I mean, when we are thinking of VMs, we are regularly thinking about gigabytes, right? Whereas on Docker containers, most of the times it's 40 megabytes, 50 megabytes, etc., etc. We are using a thing called Docker files to build our container images. We'll not go deep down there, but nevertheless, 2 interesting facts to notice here. First of all, here we are exposing the UDP port, right? On game development, we use UDP because it's faster, right? And here is a start script. A start script for our game that would basically start our OpenArena server. The second service we are using is a service called Azure Container Instances. It GA'd about a couple of weeks ago. So it's basically a serverless solution to run Docker containers on Azure, right? So basically, you give it a container, and it starts the container in a matter of seconds. You get a public IP. You can get, if you want, a custom DNS. You pay by the second. You can scale them, well, on demand as much as you want. We are also using Azure Files mounting, Alter UI in a few. And most importantly, you don't have to manage anything. You just tell the Azure Container Instances service, hey, give me 1 container of this, and in a matter of seconds, you have that running. We're also using Azure Functions. Azure Functions is a really easy way to create an API for your service, right? So think of Azure Functions as, well, the trend is to call them serverless, but, well, of course, there are servers
It's
underneath.
just somebody else's server.
Exactly. Yes. Not my problem. Mm-hmm. And they are what I like to call event-driven programming, right? I mean, you write code that corresponds to event. So Azure Functions are a really easy and nice way for you guys to build an API. For example, you can use HTTP trigger. So basically, your functions will be called when there is an HTTP call, either get call or post call or whatever. An interesting thing with functions is that you have a thing called consumption plan. So you don't need to forecast your demand beforehand. You just let them scale as much as you need to. And most importantly, you pay for usage, right? You don't pay for anything less that you use. You pay only as much as your functions are used. Another interesting feature we are using is Azure Event Grid, and I'll let you know in a few why we're using it. But nevertheless, it's a publish-subscribe messaging solution for Azure, so somebody can start publishing events. There is Event Grid, right? You can subscribe to Event Grid and get those events back. And also, there is the easy way to get notified when Azure does something. If you can see in the image, one of the publishers over there are Azure resource groups, right? So when there is a change in the resource group, so a new container instance is created, right? You can get a notification. And this notification can go to a webhook, and this webhook can be your Azure Functions. We're using Azure Storage. I'm sure you're all familiar with Azure Storage. Specifically, we're using Azure Files and Azure Tables. So Azure Files, basically, you can SMB mount, right? Well, your data, right? We're using this with OpenArena data. And with Azure Table, it's an inexpensive solution. It's a small NoSQL database that we are using to host details about our running containers. So let's dive into architecture a bit. So as discussed, we are using Azure Container Instances, where we have our OpenArena Docker container. We have not modified the source in any way. What we are doing basically is we need to count how many servers are connected to our OpenArena server. And basically, all game servers send data to standard output and standard error. So basically, we're filtering all the data that comes into standard output, and then we are counting with this if a player is connected or is disconnected. We're using a file share for assets. So on our game servers, if we had many servers that had the same data, the same assets of the game, right, that would lead to many and big containers. Right now, our game data, the 3D assets, the sounds, the logic, everything, is on Azure Files. And every time we create a new container, Azure Files is mounted, right? And so the game reads data from Azure Files. So this ends up in a smaller container, which is smaller, of course, and then faster to start. Azure Functions are discussed as our API. So we have some Azure Functions that are called to automate stuff in our game. Event Grid is used to coordinate, right, a message about Docker container creation and Docker container deletion. And finally, we're using Azure Storage, Azure Table Storage, to store information about the containers. So just a list of the Azure functions. We'll not go into, will not deep dive here, but nevertheless, there are functions to create containers, to delete containers, to list running containers, to get logs about our containers. Azure Container Instances has a really nice way to give you the logs, right, for your game servers. We're using some functions to set the state of our running containers. I mean, to understand if the container is about to be deleted or if it's running or whatever. We also have two functions that are timer triggered. The garbage collector that will basically delete all Docker containers that have 0 players playing, and we don't need them, of course. And there is the ACIAutoScaler that we'll talk in a few. Just an animation to show what's going on. In the beginning, we have no container instances. Suddenly, we want a server for our players to connect, so we create one, right? When we give the create command, the server is not up and running. After 1 minute, basically, the event grid would let us know that the server is running in this IP, so players can connect, right? Here we see 8 players that have connected and are playing the game. We need another server, or the ACIAutoScaler has run and decides that we need another server, so we have another one. Same pattern again, event grid pings us that, hey, it's running, we have a new IP. Players go there and connect. Some players leave their second container, and here is the graceful shutdown, right? So we decide, or the ACIAutoScaler decides, that we don't need a second server, right? But there are 2 players that are running it. So instead of killing the server, we call a method called ACI, a function called ACI state that sets the state of the container as marked for deletion, all right, our internal state. So basically, we don't schedule any more players to this container. We just wait for these two to finish their game. And when they finish it, here, they finished, the garbage collector, which is timer triggered, will run and delete this container. Okay? So a few words about the AutoScaler. It's experimental because, well, it's experimental. We haven't really battle tested it in any production scenario. Nevertheless, the real difference on load between game servers and, well, web servers is that on normal web servers, basically you understand the load with CPU usage and memory usage, disk I/O, and other metrics, right? This doesn't apply to game servers, right? Because I don't know how many of you are game developers, but on game development, you had a thing called a while loop, a gaming loop, right? Which basically it's while not the game has ended, do stuff, right? So the CPU usage on a running game server is, well, steady most of the time. The basic load is how many players are connected to the server, because all multiplayer game servers have a specific amount of players that they can handle, right? So we determine our load by dividing the number of currently collecting players to the total player capacity of the server. So our AutoScaler, if this load is above 80%, right, this will call ACI create, our function, to create a new instance. If it's less than 60%, it will call ACI delete to delete the instance with a smaller load. Well, sorry, not delete, set it as marked for deletion, so it will be deleted by the garbage collector. And we also have some thresholds that are configurable via environment variables. And you got sick of the slides, I know. Demo time.
Demo time. My turn. OK. So we're going to switch over to my demo machine. And I'm going to run through essentially everything Dimitris just told you about. So to start with, I'll show you just a quick look at the Azure portal here. You can see all the resources have been created. We have our Azure Functions in this resource. We have our storage accounts. We have one running container instance right now. So this was actually deployed. We'll show you later the GitHub repo. You can actually do a single-click deploy from the repo to actually set up this whole back end in Azure in your own subscription if you want to mess around with it at home. So those are all created. Right now we have just kind of a simple little admin page here which shows you the number of currently running containers and how many people are playing against those containers and the IP addresses of all those containers. So you can see we have one currently running, because you typically always want to have one. If people are going to start playing your game, you don't want to have those people have the wait time of spinning up the container for just them to play. So you always typically keep one running. I'm going to copy the IP address here, and note that we have 0 sessions. I'll start up OpenArena in a window over here, and I'm going to come in and go to multiplayer and specify my IP address. Now, we're kind of doing this manually. This is the way OpenArena works. Imagine that your game probably has a lobby server or a multiplayer matchmaking server. That's what's going to actually connect and put those players on the back end. We're doing it manually just because of how OpenArena works. So if I click Fight here, we will launch into the game. If I press the Tab key, we can see who's playing. Dimitris is already logged in down there. I am logged in up here. No one else in the audience is playing. So we can, if we wind up finding each other, shoot each other in the face. But hey, there he is.
Oh, come on.
All right, that's enough of that. He got me, OK. But if we go back over to our little admin dashboard and refresh, you can see our number of sessions went up to 2. We have 2 people playing. And that happens, again, as Dimitris said, when we launch OpenArena client on the server, we capture all the standard out and the standard error. And there's a string that we know when a user connects and disconnects. Once we see those strings, we add a person or remove a person from the session list. So we've got 2 people playing there. Now, let's imagine we had everyone in the audience started playing, and we actually needed to scale this out in real time. So I'm going to fake that just for purposes of demonstration. So I'm going to go into the Azure Functions here. And you can see we have our AutoScaler. I have set this to disabled, as it's not going to run the timer, just because I don't want to screw up the demo. If I come in here and run this function, and we look down here at the output log. Oh, I need to actually put some load on the server. Let's go over to Storage Explorer. Storage Explorer here shows you everything that happens to be in your Azure File Storage, Azure Table Storage, Cosmos DB. It's a really wonderful tool if you haven't used it. So this is our ACI details table. This is what drives that website that we saw earlier that has the number of sessions on it. You'll see the same fields and the same information here. We're going to cheat here. We're going to go into active sessions, which is still 1, because I think I'm still actually connected. Yeah. Let me exit out just so it doesn't conflict. That'll go back to 0. I'm going to lie, and I'm going to set our active sessions in this poorly sized window to 10. So now if we refresh, we see we have 10 active sessions in this game. If we go back to our portal and we refresh, we see we have our 10 active sessions. So I'll go back over here to the Azure portal. Let me clear out the log, and hopefully the cooldown timer, we've expired a minute. We'll wait for the log to show up here. There we go. So scale in is false, but scale out is true. So we actually needed another server because we're almost at the maximum capacity of that first container instance.
It works, man.
It does work. Look at that. He wrote it, so he's the one that'll look bad if it doesn't. So if I click refresh here, we'll see we get another record in our ACI details table. Now what's different about this one is that this one is set to a creating status. It says creating, if I could expand that, but it's in a creating status right now. So what we're waiting for now is for the Azure container is going to spin up. Because we've hooked up Event Grid to this, once the container is running, Event Grid's going to let us know. It's going to call our Azure function, and then we're going to go and we're going to get the public IP from that event and various other things and set the record here that we are now up and running and ready to play. So the next set of players could come in here after we do hit the actual load on the first server. They can now get bounced over to the second server and start playing. So this will take a little bit to actually spin up here. So in the meantime, I'm going to jump over to Postman, which is a fantastic debugging tool for hitting like REST endpoints and whatnot. Over on the left here, we have the list of our Azure functions. The one that I wanted to point out was we have one called ACI details. You post up the name of the container and the type of logs. And if we hit send here, what this is going to spit out are the Docker logs, which is essentially the standard out and standard error, or standard out and standard error of our OpenArena service. So we can use this for debugging. If players were connected or something bad was happening, we should see those errors right here in this text output. So you could hook this up to an admin tool front end, you hook it up to a website, or just hit it in Postman, which is what we're doing here. And all these things are just, again, REST endpoints. You send them JSON, you get back JSON. You can hook this up to any kind of front end. We're doing it pretty manually here just for the demonstration. But again, imagine a matchmaking service or a lobby service that's the thing that's actually calling all these endpoints, not just me in Postman doing it. So let's go back to Storage Explorer, refresh. We should hopefully see that we are created by now. We are. We have an IP address. We're located in the West region. If I come back to our website portal and refresh, we should now see 2 entries here. And I can tempt fate and try to connect to this one. Sometimes it takes we'll get an IP address before the port mapping finishes occasionally, but let's go ahead and try it. Multiplayer, specify the new IP address, click fight, and look at that, it's already up and running. So now I'm connected to our second service, okay? So now it's time to scale in. We've got 0 players back on the first server. There's only 1 of me on the second server. Actually, let me keep that one running. Oops. Specify. So again, we've got me running on one server, the other server is empty. So let's talk about a scale-in scenario. If we go back to our portal, let's run this ACIAutoScaler a second time. If I click on run, look at the logs here. Now this time you'll see scale in was true and scale out was false. So what this has done now is called the ACI setState method, a setState function, which is going to set the lowest load server to mark for deletion. So that's the top one because this one has 0 sessions, this one has 1 session. So this one is one that gets marked for deletion. And then again, there's a timer that would be running that would call ACI garbage collect. Again, I will run it manually for the purposes of the demo. And this usually happens so fast we don't actually see the debug log output. It's such a short method, all it does is delete the container. But if we go back over here and refresh, you can see that container is gone, but the one that still has the player on it is still running, so that person wasn't kicked off the server. So that's kind of the auto-scaling way of doing things with what we have written here so far in our demo. Anything that I'm forgetting or missing before we switch back to slides?
You were awesome.
Well, I know that, Demetrius. We already established that.
Okay. A couple of slides before we finish. So, as you can imagine, the next logical evolution is, first of all, to select an orchestrator. Of course, we selected Kubernetes to make it work. So we've started working on this thing to work with Kubernetes. There are a bunch of interesting problems there. For example, the first thing we're going to do is to use a thing called Kubernetes CRDs, custom resource definitions. Basically, we're going to save the state of all our containers or pods, if we're talking Kubernetes, on Kubernetes database instead of using external database like table storage. The other interesting problem is how to schedule the pods on each individual node. I mean, Kubernetes by default scales the pods. If you have, for example, 3 nodes, it scales the pods randomly. Right now, the best scenario in order to save in money consumption would be first to scale in the first node, and then the second, and the third. And the other interesting problem is how to do scale in, both in pods and nodes, and then scale out, right? But we're happy to work with that. If you want to follow our progress, feel free to subscribe to the repo. And summary, Brian?
Yeah, so the top link there is the link to the project in GitHub if you want to mess around with it. The second one is our sandbox. This is where we're putting all of our game developer stuff right now. We've got a bunch of Unity SDKs, mono game samples, Unity samples. We'll have some Unreal stuff up there shortly. So both client side and server side talking to Azure in the cloud. So depending on what type of developer you are, you'll probably find something up there. And then just the docs about container instances, event grid, and everything else we talked about today. And then the final thing is we're doing another session today. So if you aren't sick of us yet, please come to our second session at 2:45 this afternoon, where we are going to talk about using Azure from Unity. So we're going to talk about PlayFab, which has a booth over there if you want to learn more about them in the meantime. We're going to talk about cognitive services from Unity, Azure Storage, Azure Functions, Cosmos DB. It's a pretty cool session. It's 45 minutes long. Room 603. Come see us.
Yeah, good. Thank you.
Thank you all for coming. We'll take questions over on the side here so the next person can set up. Thanks.